let's take a look next at how to calculate the standard deviation for a discrete distribution. Standard deviation, again, it's a measure of how much variation there is within the data. Since we're dealing with a discrete distribution, we don't have that continuous data. So again, we're going to have to weight our data to really understand how that variation is impacted based on our probabilities. So let's take a look at our emergency room example. We had information on the number of patients that are visiting the ER during third shift. We know the probability of each occurring. We can calculate our expected value by taking our random variable, the number of patients, multiplied by the probability of each occurring, and then summing that value. Using our expected value, then, we can calculate our variance and then subsequently our standard deviation. The first step of that calculation, then, is to take each random variable and subtract our mean from it, our expected value. In cell D6, that's going to be equal to our random variable, so we'll start with cell A6, minus our expected value or our mean, which is cell C13. In a minute, I'm going to pull that down and automatically calculate those values for the rest of my number of random variables. So I want to make sure that my C13 is going to hold steady, hold constant. So I'm going to use my $sign to hold that cell constant for that calculation. So for the first one, I have 0 minus 2.75, which gives me negative 2.75. And then I'm going to take that equation, drag it down, so it calculates all of my other values. And then just to spot check those, it did take my A9 and still minus my mean of 2.75, which is why I wanted to hold that value constant. The next step is to take what I just calculated in column D and square it. So I'll set that equal to cell D6, and then I'll square that value. So my caret and then 2. And then I'll drag that value down as well. And then the final step is to take what I just calculated, my x minus my mean squared, and multiply it times my probability of x. So this will be equal to my value in E6 times my value in B6. And I get a value of 0.3781. Now I'll take that value and copy it down. To get my variance, that's equal to the sum of those values, which will be F6 through F12. And what we've now done is taken the sum of what we've just calculated in that column with our equation. To get the standard deviation, we're going to take the square root of our variance. So cell F14 is going to be equal to the square root, SQRT, of our cell F13. And that gives us our standard deviation of 1.6086. So while variance is a step in the process of getting to our standard deviation, variance does not necessarily mean much to most people because it's in our units squared based on how we calculated our variance. So in this case, we've got our number of patients and our mean in terms of number of patients. Our variance would be in terms of units of patients squared. Standard deviation, however, since we're taking the square root, is taking it back to our original units. So we would expect, on average, 2.75 patients based on our expected value, and then our standard deviation is 1.6086 patients. So it's telling us how much spread we have within our data. So again, here, this is why it's very important to not only calculate our values, but also graphically represent the data so we understand how much spread is within our data. Our expected value showed us where the center of our data would fit, but our variance then is showing us how much spread there is within our data. And in this case, we have a lot of variation, so we would have to plan for that variation and when it comes to staffing. From a managerial perspective, we would want to use this information again to understand how do we run our business effectively so that we can increase patient satisfaction. And in this case, it's a healthcare example, so we want to increase our patient satisfaction, and in an ER, we have to balance that risk. If we have patients that are waiting too long and they're having a serious health concern, then that's an issue. It always comes down to that business decision of understanding how to use this data effectively to make those right decisions.